Imagine a cosmic vacuum cleaner, powerful enough to suck in anything that comes too close, even light. Yep, we're talking about black holes. But what if I told you scientists have just found another intermediate black hole right in the center of the Milky Way? Intrigued? You should be. Now, let's break this down and see why this discovery is so mind-blowing. Black holes are like the ultimate bad boys of the universe, mysterious, powerful, and totally captivating. They're formed when massive stars collapse under their own gravity, creating regions of space where the pull is so strong not even light can escape. But this new discovery is not just any black hole. It's an intermediate black hole, a rare cosmic beast that's neither too small nor too big. It's just right, and it's sitting smack dab in the middle of our galactic neighborhood. Picture this. You're in a bustling city center, and in the midst of the chaos, you find an undiscovered skyscraper. That's what scientists have just done with this intermediate black hole. But why is this such a big deal? Stick around to find out. First things first, what the heck is an intermediate black hole? Well, if black holes were high school cliques, the stellar mass black holes would be the freshmen, small but mighty, formed from collapsing stars. Then we have the supermassive black holes, the seniors, chilling in the center of galaxies millions to billions of times the mass of our sun. Intermediate black holes are the juniors, not as small as stellar mass, not as huge as supermassive. They're the mysterious middle child of the black hole family, with masses ranging from a few hundred to a few thousand times that of our sun. Imagine them as the Goldilocks of black holes, not too big, not too small, but just right. And finding one is like finding a needle in the cosmic haystack. But why are these middle children so elusive? For one, they're harder to spot because they don't have the same dramatic effects on their surroundings as their larger or smaller siblings. They're too big to be formed by the collapse of a simple star, like a stellar mass black hole, but not massive enough to create the incredible gravitational pull of supermassive black holes. It's like trying to find a medium-sized dog in a world full of Chihuahuas and Great Danes. Imagine you're at a concert with thousands of people. Spotting the lead singer, the supermassive black hole, is easy because they're in the spotlight. The roadies, stellar mass black holes, are also noticeable because they're busy setting up equipment. But finding that one person in the crowd that's just the right height to blend in, that's an intermediate black hole for you. Alright, now that we've got a handle on what intermediate black holes are, let's zoom in on where this new discovery was made, the bustling heart of our Milky Way galaxy. Now, let's zoom in on the Milky Way center, a bustling hub of stars, gas, and dust, kind of a cosmic zoo, if you will. At the heart of it all lies Sagittarius A, our galaxy's supermassive black hole. But lurking nearby, scientists have now detected signs of an intermediate black hole. How did they do it? Using the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, astronomers spotted unusual movements of gas clouds near Sagittarius A. These gas clouds were moving to a different beat, hinting at the presence of another gravitational heavyweight nearby. The center of our galaxy is a wild and crowded place. Think of it as a galactic Times Square with stars zooming around, gas clouds swirling, and radiation bursting from all directions. And right in the middle of this cosmic chaos sits Sagittarius A, but recently, scientists noticed something strange. Some gas clouds near the Sagittarius A were moving in ways that didn't quite match up with the supermassive black hole's pull. These gas clouds were behaving like they were in their own little mosh pit, dancing to a different tune. This peculiar movement led scientists to suspect that another massive hole was nearby, influencing the dance. But what could it be? Enter the intermediate black hole. So, how did scientists manage to spot this elusive intermediate black hole amidst the cosmic chaos? It wasn't just a stroke of luck. They used some serious, high-tech detective work to make this discovery. By studying the motion of these gas clouds, scientists calculated the mass of the hidden object causing this gravitational disturbance. and lo and behold, it matched the characteristics of an intermediate black hole. Think of it like finding Bigfoot by analyzing footprints, except these footprints are the wobbly dance moves of gas clouds in space. Cool, right? The scientists used ALMA, a powerful radio telescope array in the Atacama Desert of northern Chile. ALMA is like a cosmic detector with a magnifying glass, peering into the heart of our galaxy with unprecedented detail. They focused on a specific region close to Sagittarius A and observed the motions of the gas clouds. These gas clouds were not just any gas clouds, they were acting like a conga line that suddenly broke formation. By meticulously tracking these movements, the scientists were able to infer the presence of a massive object. After crunching the numbers, they realized this object had a mass of about 32,000 times that of our Sun, smack in the middle of the range for an intermediate black hole. This discovery was like finding an elephant in a room full of horses and cows. So if you're like me, you're now asking the question, what is a radio telescope? How does it work? Well, stay tuned because we're going into that next. Alright, let's take a quick detour to understand the amazing technology behind this discovery. Ever wonder how radio telescopes like ALMA work? Imagine trying to listen to a whisper in the middle of a rock concert. That's basically what these telescopes do, but on a cosmic scale. Radio telescopes are giant antennas that detect radio waves emitted by celestial objects. Unlike optical telescopes, which capture visible light, radio telescopes pick up radio frequencies from space. These radio waves can come from all sorts of sources: stars, galaxies, and even black holes. And because radio waves can pass through dust and clouds that block visible light, radio telescopes can see parts of the universe that optical telescopes just can't. Here's how it works. A radio telescope has a large dish that collects radio waves and focuses them onto a receiver. The receiver then converts these radio waves into electronic signals, which are processed by computers to create images of spectra. Think of it like tuning into your favorite radio station, but instead of music, you're picking up cosmic whispers from the depths of space. ALMA takes us to the next level with its array of 66 antennas spread across the Atacama Desert. By combining the signals from all these antennas, ALMA can achieve incredibly high resolution, allowing scientists to see details that would be impossible with a single dish. It's like having a giant pair of cosmic binoculars. Why should we care about this intermediate black hole? Well, finding it helps us piece together the puzzle of how black holes grow and evolve. It's like discovering a new piece in the cosmic jigsaw puzzle, helping us understand the life cycle of these enigmatic giants. Plus, it gives us clues about the formation of supermassive black holes. Did they grow from smaller intermediate ones merging over time? This discovery might just bring us a step closer to answering that cosmic conundrum. Intermediate black holes are crucial to our understanding of the universe. They could be the missing link in the evolution of black holes, bridging the gap between the stellar mass black holes formed from dying stars and the supermassive giants that dominate the centers of galaxies. Imagine trying to understand how trees grow without knowing about saplings. Intermediate black holes are like the saplings of the cosmic forest. Moreover, the existence of intermediate black holes could explain how supermassive black holes, like Sagittarius A, got so big in the first place. One theory is that these behemoths grew from the merging of smaller black holes over time. If intermediate black holes are more common than we thought, they might have been the building blocks for the supermassive black holes we see today. And let's not forget the sheer excitement of discovering something new and unexpected in our own galaxy. It's a reminder that the universe is full of surprises, and there's still so much out there waiting to be discovered. So, what's next for black hole hunters? With this new discovery, astronomers are excited to hunt for more intermediate black holes in other galaxies. Who knows? We might just be on the brink of a black hole bonanza. With advanced telescopes like the James Webb Space Telescope, we're gearing up for a new era of cosmic exploration. Who's ready for more black hole surprises? The discovery of this intermediate black hole is just a beginning. Astronomers are now on the lookout for more of these elusive objects, both in our galaxy and beyond. With the James Webb Space Telescope, which has revolutionized our view of the universe, we might soon find many more intermediate black holes hiding in plain sight. Imagine a treasure hunt, but instead of gold coins, we're finding black holes scattered across the cosmos. Each discovery brings us one step closer to understanding the grand narrative of the universe. Who knows, maybe one day we'll even find a black hole with an entourage of planets orbiting it. And let's not forget the potential for new and unexpected discoveries. Every time we push the boundaries of what we know, we open the door to new questions and possibilities. It's an exciting time to be a space enthusiast. To wrap it up, folks, the discovery of another intermediate black hole in the Milky Way's center is a game changer. It's a reminder of how little we know about the universe and how every discovery brings us closer to understanding the cosmic dance around us. So keep looking up, stay curious, and don't forget to join us next time for more intriguing facts about our universe. Smash that like button, subscribe, and hit the bell icon so you never miss out. Until then, keep wondering, keep exploring, and remember, the universe is full of surprises.